Well, hi, welcome to my shop. Thanks for joining me. I'm going to be checking out this radio. I don't think I'm going to go on and do any work on it. I just want to check it out and see what I got here. This is my $2 radio from a yard sale just a couple of days ago. So let's look it over. It's a Philco radio, AM broadcast band only, single bander. Looks like it's got its original knobs. Everything looks great here. Cabinet is a little odd here, what's going on these corners. So I think what this is I don't know what that is. So here the kind of a mottled design in the wood here, but here it looks like, you know, striations of wood. I'm not sure what we got here. Is this just kind of a laminate put on top of the wood? Because these marks here are very odd. So I'm not sure what's going on with the cabinet. Okay, it's got a big water stain on here. I found in the past I've had some luck with just taking a hair blower, blowing on these, heating this up until the moisture is driven out, and it returns to looking like this. I've had some luck with that. So maybe we can get rid of that big stain on top. Okay, let's pull the cord out here. So someone's replaced the cord at some point. I don't think this is the original cord. And it has this unique antenna. It's a little, looks like it must be attached right to the chassis here, which would be typical. Sure looks like it has all its tubes. What happens if you tune this guy? So there's the pointer moving. Okay. Pretty tempting to turn this guy on right now and see what happens. I wonder if I should take it out of the cabinet and clean it up a little bit before I turn it on. Let's see, if you take it out of the cabinet, the glass plate with the dial numbers doesn't come with it. It stays on the cabinet. Why would that matter to me at this point? Yeah, why don't we pop it out and vacuum it off at the very least before turning it on. Oh, that's interesting. What will be found underneath here? There's the tubes. Oh, these are not the most common tubes. These are all octal tubes, I'm pretty sure. 7A8, 7B7, 7B7, 7C6. Okay, 35Z5 is common, 50L6 very common. To remove tubes, tilt in the direction of tube socket rivets until locking spring releases, then lift out. To remove tubes marked with an asterisk, rock gently with a circular motion and pull. Should your Philco ever require service, attention, call a member of the Philco service team. Guaranteed work. Genuine Philco parts. What does it say down here? Warning. Any person installing or operating this receiving set without first having obtained a license from the Minister of Transport of Canada is liable on summary conviction to a fine not exceeding $25, and the said receiving set to be forfeited to His Majesty by order of the Minister for such disposition as the Minister may direct. So, uh-oh, I don't have a license to operate this radio. So I see I'm pulling off the first knob. It reveals a shaft. Nothing to do with what I was going to say, so I won't say it. I was going to make a comment there that actually isn't true. So I will avoid that this time, although I certainly say lots of things on these videos that actually isn't true. So watch out. Like everybody, can't be right all the time. Let's take out this lower one first. The weather here, because I'm Canadian, I love to talk about the weather. The weather here is hot like heck today. 95 degrees on my deck. and very high humidity. So it's very much like Florida here. Today it's so hot. Let's see, I'm in my shop. It's really, I can only go outside for a few minutes and get quite thoroughly sweated up. So there we go. Out it comes. No other surprises in the cabinet. Something rolling around in there. Just dust and dirt. Down. Now we get a better look at the radio. Big antenna coil up here with some very light wires, easy to break. Everything's in place. Okay, so I'm going to vacuum this guy up, and I won't do it on camera. I'll save your ears for this. Okay, let's see what we got now. We can see things a little better. So this antenna is very interesting. Has individual wires here. I think you can see that on camera. Yeah, you can see it. Rather than doing what is more common, which I will show you. This is a more common antenna to find on the back of a radio like this. Instead, they've splayed the wires out here, give them some dimension, and I don't exactly know why. It must have something to do with the efficiency of the antenna. What's this say? Philco, your guarantee of safety. Guarantee of safety. Well, is there a transformer in here? I don't see one. And it's got a 35 Z5 and a 50 L6. You know, that's screaming hot chassis out here. I'm not sure I really want to explain in detail what that means, because there's some fantastic websites. If you don't know what a hot chassis is and you're fiddling around with radios like this, you had better find out. So just Google hot chassis problem. There's quite a few, and read a couple of different websites on that. And it's not the easiest thing to get in your head what is going on that makes these chassis go hot. Okay, now what's stopping us from turning this thing on? There's really nothing. Let's look underneath. See if we can find some surprises under here. Has anybody been under here? Oh, look at that. Capacitors all changed. Well, he didn't change this one. Why? He's changed all these. Done a nice job. Look, he covered up the leads nicely. So whoever did this work did a nice job, but they left this in. This is, you know what? This is the capacitor that connects the B- to the chassis. There's another one underneath here. What's he done? He's paralleled it. There's a little one under here. Why would you do that? Get this out of here. So this is part of the hot chassis danger right here, that this capacitor could be shorted. This old guy. Right underneath it, he's got the new one. Yeah, Philco capacitor. It doesn't tell you the size. It just has a stock number on it. But look, it's completely open in here. It's horrible. It looks like a capacitor just slid inside of a paper shell. It's more than that. So it's kind of weird. There's a lead here and a lead on this there. What's going on with this thing? Did I cut this out prematurely? Something special about it. really does look like a capacitor just shoved inside of a cardboard shell. But the strange thing is, what is going on right here? It's got a lead here and a lead here. What's going on? So I'm going to cut this thing open now. Can I just cut down this shell? Peel it open? Why not? Why not do that? Some big black on here, I think, is indicating that this is the outer. It's the outer, but I don't know. Okay. I don't know what they're doing here. Let's find out. So as I'm saying, if this capacitor is failed, I think I might be learning a lesson here. But if this capacitor fails in terms of getting a short through it, then you've basically got the chassis connected directly to one of these two. And you put this in this way or that way. That's part of the story. So we'll pull this off. Oh my gosh, there's more to this thing. I blew it. I blew it already. That's a bloody coil. Oh, I cut right through. What a dork. Okay, so the smart guy left it in there, and the dumb guy has cut it out and cut it apart. Oh, you can see the actual terminal now. You know what? I rushed in, didn't I? I rushed in. Fools rush in. I rushed in. I was a fool. Okay, so coil between what is obviously the B minus point and the chassis. It's not the end of the world. I think it may be more important to, well, it's kind of weird, isn't it? Coil. How's that going to stop AC from getting ya? I don't know, but I think we're better off without that capacitor in there. Now, perhaps the last guy, being a smart guy, tested this thing and decided it was okay. Why you would bother putting in the parallel capacitor here, I don't know. Because this is really a safety feature of the radio, although the coil doesn't quite make sense. Most radios, they use a resistor in parallel across this capacitor, a large resistor. And what that does is, if you're going to get a shock, it's going to be a tingle shock. I get tingle shocks in my shop with some regularity. Because of the older instruments I have these kinds of plugs on them. And occasionally I get it plugged in such a way that there's a voltage to get a shock off of, not a lot of current behind it though. So you get a little tingle. Makes you go, ooh. Now, got all kinds of, look at this arrangement here. Yikes. Yikes. So this is not the best technique here. So, okay, so now we know what we got. Anyway, good thing I looked under here because, wow, it's always a surprise. I think we can assume the person took enough care, knew enough of what they were doing, that even this kind of wonky thing is probably okay, as long as we don't fiddle with it too much. So here's the power cord coming in. Well, I think we can turn this guy on. I don't think there's any doubt about that. Now, the thing about my shop here is I have a way of turning this on and keeping if there's a short circuit in here, keeping this from popping a fuse in my house, or worse yet, setting the radio on fire. So I wouldn't want that to happen. So I'm going to use dim bulb system to control the amount of power that goes in here. You can see my bulbs right here. Okay, Okay, so we're going to set it so the power goes through this bulb. I think it's a 25 watt and a 40 watt, or 40 and a 60, I can't remember now, but this is the lower one, so that will restrict the power coming in here. If there's a problem, this light is going to come on full blast and we'll know right away. Won't worry about this. Okay, I think we're ready to go here. Now, there's a good chance this chassis will be hot, but in my shop, I use an isolation transformer to power things like this. So the rest of my equipment is plugged into regular outlets, but this is not. This is plugged into a isolation transformer. So I really can't get a shock while it's here working. That's the theory, but you know, to say to yourself you can never get a shock is a bad thing to say to yourself. That's bad. But I can go ahead and touch this chassis. I'm quite safe. I'm on a rubber mat. I'm wearing rubber-soled shoes here. Slippers rather, and I'm smart enough to keep my hands away from anything grounded. So, but just the same, I really can't get a shock from this. Unless, of course, there's something wrong in my shop. Oh, this has all been repaired here. So this radio has gone through the hands of someone like me. So I'm really reassured we can turn this guy on. Okay, so there's no power supplied here yet. So switch is off. We'll now supply power. You see absolutely nothing happening. Perfect. That indicates the switch is working. So power off, switch on. And now I'm going to power this up. So you need to keep an eye on this bulb. Initially, it should go bright, dull, and then come up again. That's what it should do. Let's see. Bright. Where's the dull? Okay, it's dulling down. Dulling down. Now it should start coming up again. And the radio should start working. It's going down, it's going down. Come on, little radio. Now we're supplying it with very low voltage here. The radio's probably getting like 60 volts or something. It just may not be enough. Give it a long time now to warm up. Not a thing. Okay. So the dim bulb behavior tells me that there isn't a serious short circuit in this radio anywhere. So I'm going to boost the power coming to it simply by screwing in another bulb here. There we go. So now it's running at around 110 volts. So it's actually running at a normal voltage. It's working. So, I know someone else has been on this radio. There's a good chance they did everything, but maybe not. So what I'm going to do is I'm just going to turn the IF cans a little bit to see if they just go down in signal strength, or if they can come up too. Okay, so this radio's peaked up. Next question would be, somebody can peak it up just like this without any instruments. You just tune in the station you like and adjust the IF cans until you get the loudest signal. You can do that. The problem is the local oscillator may be off a bit, and then you may end up a little off on the dial. But if you don't have the instruments, you can still peak up the performance on the radio. So I want to find out if the local oscillator is working properly in here. And the way I'm going to do that is we're going to utilize I think it works. Just checking. Yep. We're going to utilize my SDR radio here. We're going to try to get up on the screen. You know, I'm going to stop the video for a minute, rearrange some equipment here, and then we'll carry on. Okay, so here's a view of the spectrum display from my Sdr software-defined radio. What you're looking at, in the upper part, you see a blue bar. It says medium wave. That's the band that all the AM broadcasts are done in. So you see the bottom starts at around 530 and the top ends at 1600. I think today it actually ends at 1700 in North America. But so that's where all the AM stations are. Right there. Now, the local oscillator, let me just tune the radio a little bit here. Okay, so it's not appearing yet on here, or you'd see something moving. So let's go back to the camera here. Okay. Now you can see the Sdr display in the lower right, and you can see the radio right here. Well, this is the antenna to the Sdr. You can see already things are happening there. My hand on it, you can just see that. And this is just a little coil of wire here, just attached to this cable. Nothing fancy about any of this. Okay, might look a little fancy. It's not. Just happen to have this, so I use it. So you could make just a coil of wire, hook it up to the antenna terminals on your Sdr radio, on the sitting radio, and the next thing you know, you'll get this kind of display. So you want to put this somewhere where we suspect the local oscillator is being radiated, the frequency is being radiated out. And so anywhere around the big tuning capacitor would be good. Stick it here. Now, what happened on the radio? So you see something is showing up just above 1 million. Also something showing up around 600, that might have been there. So if I tune this, it will vary the local oscillator, and we should hopefully see it on the Sdr. Here we go. Okay, so quite clearly that yellow whitish line is the local oscillator. So what we're going to do now is we're going to tune to a known station. A little tricky with no dial on here. Okay, so let's measure the, I'll wait for them to identify the station. I'm not even sure what it is at this point. It's either 590, 640, or 680. Keep our ears open when they declare who they are, but in the meantime, let's look for the local oscillator. It's just above 1 million there. Right here. Frequency is 1.035. Okay, 1.035. The local oscillator in here, I'm going to have to guess, is 455. Do a little bit of arithmetic here. A little wee bit. So the local oscillator is running at 1035. Subtract 455 from that. Hope I do this right. He just said 590. Did you hear him? And I just calculated 580. So a local oscillator is slightly off. Not to worry about that. The dial's not that accurate anyway. That's close enough. That's close enough. So that tells me whoever worked on this radio did a pretty complete job, and now I've got it. So whoever it was, thank you very much. I don't think there's really much we can do to this radio. Let's just try the front end a little bit. So the front end is going to be tuned by one of these two trimmers here. One is the oscillator trimmer and the other is the front end tuning. So identify which one's which by interfering with them and listening to the effect on the radio. One of them will just make the radio fade in and out, and the other one will tune it back and forth. This one here seems to tune it. And the way we'll prove that is I'll interfere with this, and then I'll tune the radio, see if we can tune it back in. Not really. Not really. I'm not interfering enough on the other side. Now this, look, the antenna is connected right here. So this has to be the front end part of the capacitor. So connect it right there. So let's just adjust this a little bit. Wow, okay. Not getting much effect there. So there's a coil here. This is probably the antenna transformer. Doesn't look like it's adjustable at all. It's all up to this capacitor here. I didn't hear any change. I have to put some instruments on it to see if there's any change. Yeah, I don't think I can improve this at all. I think that's it. I think that's the end of the road for this radio. Nothing for me to do. Dirty control. Hey. Not dirty enough to worry about. Okay, here we are. Nothing for me to do. The most I did was remove a part I maybe should have left in, but maybe not. As for replacing the coil here, well, I'm not going to rush into it. I think if I were to do anything, I would just put a resistor like I've seen in so many other radios across the chassis capacitor, like 100K or some big resistor, but not to worry about it now. Hey, thanks a lot for watching, and I'm going to get back to that big Nordmendy next. Thanks. See ya.